Alright, so here we are talking about Spearman correlation, which is another kind of correlations that we are going to learn today. So just now we have talked about Pearson correlation, so which is a correlation coefficient that we use when we have a continuous data or data that in a scale level of measurement. But Spearman is less restricted. So later on we look at this. So Spearman's correlations is also called Spearman's rank order correlations, or just Spearman in short. So this is the non-parametric version of Pearson correlations. So in a way, it's very similar to Pearson, but with less assumptions. So Pearson correlation requires you to have a normally distributed data, but for Spearman correlation, you don't have to have a normality. So when your data violate these assumptions, you can consider to use a Spearman correlation. So just now we are using R to represent the Pearson correlation coefficients, but here we use this RS. So S here means Spearman. Sometimes people use it as a R and then a small s. And you can also use this Greek letter called rho. Here this symbol. So when people see this symbol, they will know that that is Spearman correlations. So the same thing is also measure the strength and direction of associations between variables. So it can be two variables, it can be more variables, but here we can use the ordinal scale, right? Not just continuous. You can use continuous data as well, but you can also use ordinal data here. So it is less restricted than Pearson. But Pearson is more powerful because it is not affected by tight ring. So every method has its pros and cons. So we will look at this. So these two are different in some ways. The way it works your data for Spearman is that it first rank your data and then applying the Pearson correlation to those rings. So what are we talking about when we talk about rank? So later on we will look at this. When we look at the example, then you will know how Spearman rank the data first before it calculate the coefficient. So Spearman is affected by ties, a data point that have the same rank. So the same data values, they have the same rank. So this is a limitation from this method. But every method has its own limitations. So this is the limitation for Spearman. But for Pearson, the limitation, for example, it is affected by outliers. So it has pros and cons. So we will look at this difference in that later on. So this is another important part of Spearman correlations. There need to be a monotonic relationships between your variables. Later on I will show you what is this. So this is the assumptions of Spearman. Only this. Your variable can be either ordinal or a continuous variable, and then you have also monotonic relationships. For Pearson, you have linear relationships. Here you have monotonic relationships. So unlike Pearson, Spearman has a lot less assumptions. So when Pearson assumption is violated, then you may consider Spearman. So I have talked about this earlier on, isn't it? But what is this monotonic relationships? So when you see this graph, maybe it will be clearer. So a monotonic monotonic graph is the one that always increase or always decrease, but not both, right? So graph that is always increase or always decrease. The plotting graph, this graph here, is showing you some of the monotonic functions. So these two only. Right? So when x and y, so when x increase, y increase. It doesn't matter the rate of this increase. Here it's quite slow, here it's quite fast, and then very slow again. But as long as it keep on increasing or it keep on decreasing, so it cannot be, for example, here it decrease and then increase and decrease. So this is not monotonic. So when you see this one, it may not be a straight line. It can be a curved line like this. For Pearson, it needs to be about in a straight line, isn't it? For Spearman, you don't have this to be in a straight line. As long as it is monotonic, it is okay. Monotonically increasing. So what it means is that when x increase, y also increase, and this y will never decrease. Okay. Monotonically decreasing, so as x increase, y will never increase. Let's look back to this graph and it will be easier for you to see. For monotonically increasing, so when x increases, value of y will also increase and it will never decrease. For the second one, monotonically decreasing, so when the value of x increase, the value of y keep on decreasing and it will never increase. So if a graph is not monotonic, so it means when x increase, y can decrease and increase and decrease again. So it has both increase and decrease. So if this thing happen, this is what we call a non-monotonic graph. So this is what it means here. So when the relationship of two variables is curvilinear, it has a curve like this. This one curve, isn't it? This one also curve. Spearman is more useful than Pearson's. So because the correlation of this variable is being underestimated by Pearson, thus it weakens the R value that you are going to calculate. So sometimes Spearman and Pearson will give you the same answer. So sometimes Spearman and Pearson will not give you the same answer. So in the case of this curve, if your data looks like this, Spearman will give you a higher value. Right? So if you use Pearson, it will weaken the relationships. So you will have a lower R value. But you have to remember that linear relationships are also monotonic because it follows this pattern. When x increase, y increase. When x increase, y decrease. See, it follows this pattern. So linear relationship, straight lines are also monotonic. So this is why Spearman can be used with linear relationships, right? So this is the example for Spearman correlations. So we are working with rank here. So we have restaurant in Kuching. So restaurant in Kuching were inspected by two world-class chefs for Kitchen Nightmare TV show. So first we have Chef Gordon Ramsay, and then this very well-known chef here, Chef Donald. This is a better chef than Gordon Ramsay. So these two chefs were asked to give a rating to these 10 restaurants. So rating from 0 to hundreds. 100 is very good, 0 is the worst. So the ranking for these 10 restaurants are given. So before we look at the table, let's look at the hypothesis first. So firstly, we have the null hypothesis. There is no relationship between rating given by Chef Ramsay and Chef Donald. So meaning to say the rating given is not consistent. The alternate hypothesis, there is a relationship between ratings given by both chefs. In a way, we can say that rating given is consistent, right? So these are the tables. We have 10 restaurants, and these are the score. This data you can download in our website as well. So let's try to open this one. So this is our data for this. So we have a rank given by Chef Ramsay, and we also have rank given by Chef Donald. So these are the score for these 10 restaurants. We have 10 here. Right. So for a Spearman, the steps is the same as how you do Pearson's. So this is quite easy for you. You go to analyze, correlate, bivariate, and then you bring over this two over here. And then since this one is not Pearson's, you can untick this and then select Spearman instead. So if you need, so here you see this, it won't give you mean and standard deviation because these are ordinal data. So for ordinal data, by right, we don't calculate mean and standard deviations because it makes less sense. Right. So this is all that you need. And then these are your output. So when you look at this is your p-value. This is 0.002, and then you also have your raw value or R as R for Spearman. This is 0.855. So how you interpret this is the same as how you interpret Pearson R. So this is very close to 1. This is a positive value. So we can say that there is a very strong positive correlations between rating given by Chef Ramsay and Chef Donald. So in theory, how does Spearman works? So first, you have this raw score by rating by Chef Ramsay, and then also rating by Chef Donald. So first, the Spearman work by ranking your data. So like here, for example, the rank 1 is given to the highest score, and then 0, and then all the way to the lowest one. This is the lowest value here. This is rank number 10, right? So 1 is the best, 10 is the worst. So the same as rating given by Chef Donald here. The Spearman will first rank this data. Then after that, by using this rank, substitute it in this formula here. This D is basically the difference between this rank and this. 1 minus 3 is minus 2. But we want it to be a positive value. So that is why we square it. So negative 2 squared is 4. So with this, we add all of this together. This is summation of D squared. So this is this part, which is 24 here. All right, so we substitute the value in, then you get 0.855. So which is the same as what we have calculated in SPSS. So this is the raw value. Rho equal to 0.855. So this is how you report this. R and a small s, or you can use the Greek letter rho. And then the degree of freedom. Degree of freedom is n minus 2 because we have 2 sets of ratings. and then you have to state your p-value as well. So this is how you report this. A Spearman correlation was run. So you first have to mention what kind of correlation that you are running, that you are doing, right? So this is to determine the relationship between rating given by Chef Gordon Ramsay and Chef Donald. So they are a strong positive correlation between rating given by both chefs, which was statistically significant, and then you substitute this value in. This is the degree of freedom. This is the raw value, and then p-value right here. Okay, so another thing is Kendall Tau. This is also another kind of correlation analysis. So when you need to do this, so let's look at here. So Kendall Tau is another non-parametric correlation, just like Spearman. So when you decide to use Kendall Tau and Spearman, is that when you have so many tight rings. So what is tight rings? Well, when you rank the score, like what we did just now, here, and then you have so many scores that have the same rank. Meaning to say, you have the same values. The same value meaning to say same rank, isn't it? So if you have a lot of this same rank, then Kendall Tau should be used. So if not, and then you just use Spearman. So let's talk about the similarity between Pearson and Spearman, because I got asked these questions a lot by students. So even last night, so I got one master student is asking me this. So what is the similarities between Pearson and Spearman? So when we use Pearson and when we use Spearman. So these two, it's about measuring relationship between variables. And the coefficient value is between -1 to +1. When it is close to 0, it means the relationships is very weak. When it is 0, no relationships. Close to 1 means to say it has a strong relationship. So in this sense, and how you interpret R and also rho is the same. Right? So if the distribution of your data is neither linear or monotonic, for example, this is a quadratic functions. So both of this, Pearson and Spearman, will give you 0. But it doesn't mean that it doesn't have a relationship, isn't it? You see this kind of pattern here. So in this case, both of these are not really useful to describe this kind of data. Right? So these are the similarities between Pearson and Spearman. But what are the difference? So here I have listed down in the form of table. So this is something that we have discussed earlier on, just to refresh your mind about Pearson and Spearman. So Pearson is about linear relationships. So linear, we are talking about straight line. Okay. Spearman, it doesn't have to be a straight line. It can be a curved line as long as it is a monotonic relationships. So you may want to refer back what is monotonic relationships. For Pearson, it's about two continuous variables. Spearman, it can be about continuous or ordinal variables. So Pearson, it takes on your raw data. So that is why it is very sensitive to outliers. So it doesn't rank the data first, unlike Spearman. So when you rank the data, then these outliers does not make any difference. So this is not sensitive to outliers. So that is why in Pearson, one of the assumption is you should not have significant outliers. But for Spearman, you don't have these assumptions, isn't it? And another one, which is the most important thing, is the parametrics and non-parametrics. Pearson, you need to have a normally distributed data. Spearman, you don't have to be. Alright. So based on this, you can judge on when to use Pearson and when to use Spearman. So if you are not sure whether your data distribution is linear or monotonic, then just plot, scatter plot, then you can see. Right? So that is Pearson and Spearman. So in Jamovi, the process of computing Spearman is basically the same how you process how you compute Pearson's. So I won't show you here. So that's it. We have come to end of this correlations. So next, we are talking about correlation between categorical variables. So here we are talking about continuous variables and also ordinal variable. So what about nominal variables or categorical variables? So this we will talk about this in the next topic, so which is chi-square. So that's it for this topic. Thank you very much for listening.